Let's do an example to show how simple Simpson's rule and how effective it is, how close the approximation can be in a very simple computation. Well, let's use Simpson's rule to approximate this interval right here. I drew a picture basically of what that looks like. This would be the point -1 e to the -1, which is 1 over e, so something like roughly 1/3. This would be 0, 1. And this one would be 1, comma, e. So this is our A, M, and B. We'll generalize it later so it doesn't have to be symmetric about 0. Okay, so here's our function. Here's our A, M, and B. I'll be consistent from the previous talk. So this, according to Simpson's rule, is going to be approximately 1/3 of f of -1 plus 4/3 f of 0 plus 1/3 f of -1. The -1, 0, and 1 are just A, the midpoint, and B. And then Simpson's rule magic numbers are 1/3, 4/3, 1/3. Okay, so this is exactly equal to 1/3 times 1 over e plus 4/3 times 1 plus 1/3 times e. And I plugged that into the calculator and got approximately 2.36205. Note that the exact interval, I'll just write it underneath here rather than working it out. I actually integrated it. Exact value of the integral is 2.350423 and so on. So accurate out to the 100th. It's only off in the 1 in the 100th place, but look how trivial this computation was. We just evaluated the function e to the x at 1, 2, 3 points and took a linear combination of them, the one specified by Simpson's rule, 1/3, 4/3, 1/3. Amazing that that works so closely. And especially, look how wide the spacing is. This is a whole 1. It's a unit. It's not like 1/10 or 100th or 1,000th. That's a very wide interval. So just to compare, if we let h equal 0.1, so in other words, let's make A -0.1, the midpoint M would still be 0, and B would be 0.1. So we've really made it much closer around 0. Let's see. Exact integral, -0.1 to 1 of e to the x dx exactly is 0.2003355 ... Simpson gives an approximation. I'll go ahead and say -0.1 to 0.1 e to the x dx is approximately equal to 0.1 over 3. Oops. -0.1 plus 4 e to the 0 plus e to the 0.1. Notice what I did is this is supposed to be 1/3. This is supposed to be 4/3. This is supposed to be 1/3. Well, I pulled the 1/3 out. And then this 0.1 is simply because that's the width of the interval from 0 to 0.1. Okay, and this value is exactly, it's our approximation, but it's 0.200333611 ... So when h is very small, look how close we are. 20033, out to 5 decimals past the decimal point. So the smaller the interval is, of course, the better you're going to do. We should never need the trapezoidal rule again. Trapezoidal rule was excellent, but this is even superior. It's so easy to compute. E to the x is not anywhere close to being a linear function or a quadratic function, and the estimate using Simpson's rule is still very, very good. Okay, the next thing we're going to do is generalize it so that we don't have to integrate from, -1 to +1 or negative alpha to positive alpha. We'll generalize it in the next video.